Hi folks, welcome back to Physics with Captain Rod. Okay, so I'm making this video here to describe a concept called work. Extraordinarily important concept in physics and in dynamics. So first of all, work is done when a force is applied to an object, and as a result of that force, the object starts moving. So in this picture right here, when this force is applied to the object and the object starts accelerating or sliding to the right, then that force is doing work. Now, here's how work is calculated, right? Work is force times distance. So it's a number that has units of Newton meter. And in the SI system, 1 Newton meter is called 1 joule. Or in the English system, it's the pound foot or foot pound. And to my knowledge, the foot pound doesn't have its own little pet name. Now, when we calculate work, there's a little qualifier though. When we say that work is force times distance, the force has to be parallel to the distance. So in the second example, or in the second picture, right here, if we apply a force as shown, and the object moves along this floor in this direction, when we calculate the work, we want to break that force into components. And this animal is adjacent to theta, so that one's F cosine theta. This animal is opposite theta, so that one is F sine theta. And when we calculate the work, we take this one. So the work done here would be F cosine theta times d, whatever distance this object moves. Now, we can also define work a little stronger than that mathematically. So we can imagine an object with some sort of force vector applied to it, and then we'll imagine that object moving a distance, maybe ds in this direction, where s is just some variable here. All right, and then there's some sort of angle between them. Then the work done across the distance ds would be a differential work, because it's a differential distance. So that would be magnitude of F times the cosine of the angle between F and the ds vector times the magnitude of ds. Okay, this is the component of this force in the direction of the displacement. And then again, times the displacement. And this can be defined in terms of vectors. So when you have a vector times another vector times the cosine of the angle between them, that's what we call a dot product. So we could define mathematically the work term to be dW equals F, your force vector dotted with your displacement vector, in this case infinitely small. Then the total work done, or your net work, I'll put total here, these would have to be added all up. So if we take F dot ds from, we'll say, position 1 to position 2, we would get the total work done on the object. Now, some things that are really important about work, again, I'll define what it is and why it's important in another video, but right here, right now, I want to talk about signs, like plus and minus signs. So if I take an object and I look at three forces on it, let me say F1, F2, F3, oh, and let me add another one here and say F4 here, okay? If this object moves to the right, a distance, let's say d here, F2 does positive work because the force is in the direction of motion. F4 does negative work because the force is in the opposite direction of motion. And forces 1 and 3 don't do any work at all because the forces make a right angle to the distance. Okay, that's really important to realize. Let me go through another example here. If this object moves this way a distance d, force 1 is doing positive work, force 3 doing negative work, and forces 2 and 4 not doing any work at all. So this video here is just meant to be kind of an introduction to how work is calculated, right? It's force times distance, but the force has to be in the direction of the distance. And then that can be defined in terms of dot products. When we have a force vector and a differential displacement, we'll call this a ds vector, then the work done is F dot ds. And then hence total work done on a system is integral F dot ds from position 1 to position 2. So I hope that this video was a decent introduction to the concept of work. We're going to be talking about this quite a bit. Have a great day.